Welcome to Chapter 6, Section 4. Today we're going to be talking about some special types of quadrilaterals, rhombuses, rectangles, and squares. To start us off, we're going to go over the definitions of these quadrilaterals. So first, a rhombus is a figure with four congruent sides. This one should be marked as well. So rhombus is a quadrilateral with four congruent sides, as you can see from the picture that is labeled rhombus. It has all sides are congruent. A rectangle is a quadrilateral with four congruent right angles. So we don't talk about anything about the sides, but it has to have four right angles. All of its angles are right. And lastly, a square is a quadrilateral with four congruent right angles and four congruent sides. So all the sides are congruent, all the angles are congruent, and they're all right angles. Okay, let's do some practice. So in the diagram, ABCD is a rectangle. So the first thing they ask is find AD and find AB. So first of all, let's look. AD is this side right here. Now in that previous definition of a rectangle, they did not mention this, but you probably would remember this from math classes in the past, that opposite sides of a rectangle are congruent. So the opposite side to AD is BC. So AD is also going to be 5 because BC is 5. Those are those two opposite sides. They're congruent. They're also asking us to find AB, which is this side right here, highlighted in green. Well, the opposite side to AB is DC. Well, we know DC is 8, so AB also has to be 8. So if we want, we can write this on the side that AD is equal to 5 and AB is equal to 8. Part B says find the measure of angle A, angle B, angle C, and angle D. Well, what do we know about rectangles? We know that all of its angles are right angles. It has four congruent angles. So we know that each of those are 90. So we could write, if we wanted to, measure of angle A equals measure of angle B, which is equal to measure of angle C, which equals measure of angle D, because they're all congruent, which equals 90 degrees. They're all 90 degrees. Okay, practice. In the diagram, PQRS is a rhombus. Find QR, RS, and SP. Well, we know that in a rhombus, that means we have four equal sides. So let's look at this picture. We know that PQ is 6, one of the sides is 6, and a rhombus has four congruent sides. That means this side is congruent to this side to this side. Since one of the sides is 6, that means all the other sides have to be 6 in order for it to have all congruent sides. So QR is 6, RS is 6, and SP is 6. All the sides are 6. Okay, we have a couple corollaries for you to write down. The rhombus corollary, now this relates to its definition. If a quadrilateral has four congruent sides, then it is a rhombus. So, for example, in this picture, AB is congruent to BC, which is congruent to CD, which is congruent to AD. They're all congruent sides, so this is a rhombus. And a rectangle corollary, if a quadrilateral has four right angles, then it is a rectangle. So that means measure of angle A is equal to measure of angle B, which is equal to measure of angle C, which is equal to measure of angle D, which is 90. Then that quadrilateral ABCD is a rectangle. And finally, our square corollary. If a quadrilateral has four congruent sides and four right angles, it needs to have both of those, four congruent sides and four right angles, then it is a square. So that means all the sides are congruent. AB is congruent to BC is congruent to CD, which is congruent to AD. And the measure of each of our angles, angle A, B, C, and D, are all 90. Then ABCD is a square. we are going to use these corollaries to name quadrilaterals. So use the information in the diagram to name the special quadrilateral. Well, the first thing that sticks out when I look at this picture is that all of its angles are labeled as right angles. Right here, we know they're all right angles. For right angles, since they're all right angles, we know they're all congruent. I'm going to jot down that note right here. 4 congruent right angles. Now what do we know about the sides? Well, one side right here is 3. The other side right here is 5. The biggest takeaway from this is that they are not congruent. They have different lengths. So we can say sides are not congruent. We don't know anything about the sides being congruent because they're not congruent. If we wanted to, we could use our rectangle properties and label the other sides. This side would be 5, and this side would be 3. Oh, whoops. Sorry, there we go. This side would be 3. But we don't necessarily need to do that for this problem. So what quadrilateral do we know has 4 congruent right angles? And that would be a rectangle. Okay, I want you to pause the video and try these two. We'll go over it in a moment. Okay, let's go over this problem. The first thing with A that stands out to me is that each of the sides are labeled 4. Well, that means that they're all congruent. They all have the same measurement. So we know that this shape has 4 congruent sides. Do we know anything about the angles? No, we don't. The angles aren't labeled on this diagram. So, what quadrilateral has 4 congruent sides? That would be a rhombus. Squares also have 4 congruent sides, but because we don't know if the angles are congruent or not, all we can say is that this is a rhombus. Part B, what I notice when I look at this picture is I notice that all the angles are right. If all the angles are right angles, that means they're all congruent. So we have all congruent angles, all congruent right angles. And I also notice that all the sides are congruent because they're marked that way. So all sides are congruent. Well, what quadrilateral has 4 congruent sides and 4 congruent right angles? That would be a square. Now, here's my next question to think about. What happens if you just looked at the angles and said, hey, that has 4 right angles? That sounds like the definition for a rectangle. Well, technically, this is a rectangle. It follows that definition as 4 congruent right angles, but it's not the most accurate name because it also has 4 congruent sides, so it's a square. Similarly, you could argue that this is a rhombus because it has 4 congruent sides. So it is a rhombus, but its most accurate name is a square because you also need to consider that it has 4 congruent right angles. So overall for B, you could call it a rhombus, you could call it a rectangle, but its most accurate name is a square because that name of a square takes in all the different properties that this quadrilateral has. Its most accurate name. Okay, this is now a great time to pause the video and take out your theorem packet if it's not out already. So theorem 6.10, the diagonals of a rhombus are perpendicular. So that means, let's see, if we look at our diagonals, remember the diagonals are the lines that connect non-consecutive or not next to vertices. So we have that diagonal right there, AC, and our other diagonal, BD. Now where the diagonals meet, we have right angles that are formed. They're perpendicular. AC is perpendicular to BD. Okay, solve for x. ABCD is a rhombus. Find the value of x. Well, my key information right here is it's a rhombus. And let's see, I see my two diagonals, AC and BD. They intersect at point E. Well, what do I know about diagonals of a rhombus? Well, from theorem 6.10, we know that when they intersect, they form 90-degree angles. So this is a 90-degree angle, this is a 90-degree angle, this is a 90-degree angle, and this is a 90-degree angle. Now let's see, I want to find x right here. I know that we have, let's see, a 60-degree angle, and then we know we have all these 90-degree angles. The thing that I notice when I look at this picture is I notice this triangle right here. Purple triangle. Well, the purple triangle has, let's see, an angle of 60 degrees, an angle of 90 degrees, and an angle of x degrees. That's 3 angles. Now, what do we know about angle sum of a triangle? It has to equal 180 degrees. So that means that 60 degrees plus 90 degrees plus x degrees has to equal 180 degrees. Now, all we have to do now is just solve for x. So let's see, 60 plus 90, well, that's 150 degrees, plus x degrees equals 180. I solve for x by subtracting 150 degrees on both sides. And I'm left with x degrees equals 30 degrees. And that right there is my final answer. This right here is 30 degrees. Okay, I have another theorem for you. Theorem 6.11, the diagonals of a rectangle are congruent. So that means this diagonal right here, which I'm going to re-highlight in green, AC, that whole diagonal is congruent to BD, the diagonal I'm highlighting in blue. They're congruent in a rectangle. Okay, find the value of x. So ABCD is a rhombus. Well, what do we know about rhombuses? Let's see. We know that they have two diagonals, and the diagonals intersect at 90-degree angles. So this is a 90-degree angle, this is a 90-degree angle, this is a 90-degree angle, and this is a 90-degree angle. So x is a 90-degree angle, or x is a right angle, which means that x is a right angle, so x is equal to 90 degrees. Okay, rectangle EFGH. Find the value of x. So the first thing to note is that when they say find the value of x, they're talking about this whole entire diagonal, not just that one segment, but the whole diagonal FH. Well, let's see. The first thing I notice is that EG, that whole diagonal, I'm highlighting all of it in red, that's 12. Well, first of all, this is a rectangle. What do I know about rectangles? Well, from theorem 6.11, the diagonals of a rectangle are congruent. So that means that diagonal EG is congruent to FH. Well, EG is 12. That means FH also has to be 12, so x is equal to 12. I want you to try this last practice problem on your own. I'll pause the video and then we'll go over it in a moment. This problem is a little bit more difficult because it allows you to apply things from the whole entire lesson. So the first thing that I want you to take note of is that this is a square right here. So what do we know about squares? We know that squares, all 4 of its sides are congruent, and we also know that all 4 of its angles are 90 degrees. Well, if we look at this square, it has 2 different diagonals, diagonal LJ and diagonal KM. Well, do we know anything about diagonals of a square? We do know that diagonals of a rhombus intersect and form 90-degree angles, right angles. But, well, what do we know about diagonals of a square? Well, a square is a rhombus. Every square is a rhombus. And we know that because of the definition of a rhombus. The definition of a rhombus says that a rhombus has 4 congruent sides. Well, so does a square. So every square is also a rhombus. Just the square is the most accurate name for a rhombus. So because KLMJ is also a rhombus, that means its diagonals intersect at 90-degree angles. So this is a 90-degree angle right there. The next thing you should notice about this problem is this triangle right here that I'm highlighting in purple. And this triangle has 3 angles, that 90-degree angle, and 2 angles that both have x degrees. Well, I know that the angle sum of a triangle is 180, so that means 90 plus x degrees has to equal 180 degrees. Well, if I combine like terms, that's 90 degrees plus 2x degrees, because there are 2 x's, to equal 180. If I subtract 90 on both sides, I'm left with 2 times x degrees equals 90 degrees. If I divide by 2 on both sides, I'm left with x is equal to, sorry, I'm going to rewrite this over here. I'm running out of space on my tablet. That is x is equal to 45 degrees. And that right there is my final answer. Thank you for watching this video on different types of quadrilaterals.